Welcome to Chapter 2, Crowdsourcing for Organization Strategy. This lecture, prepared by Dr. Jabbar Qasim Al-Maliki for the School of Computing at University Utara, Malaysia, focuses on sentiment analysis and social media management. Historically, organizations relied on internal expertise to make strategic decisions. However, in the digital economy, internal knowledge is often limited by its own boundaries. Organizations are expanding their reach, connecting to a vast network of external insights through social media and collaborative technologies. This outward approach is called crowdsourcing. It is the deliberate strategy of using digital platforms to obtain ideas, feedback, and solutions directly from a large group of people. Those people, whether they are customers, employees, suppliers, or local communities, are your stakeholders. When you combine their varied perspectives and expertise, you generate what we call collective intelligence. For computer science students, this shift transforms our view of platforms like X, YouTube, and LinkedIn. Beyond their code and interface, these platforms generate massive, continuous streams of unstructured data. Extracting strategic value from this noise requires the application of rigorous computational analysis. This chart shows the difference in data velocity. On the left, traditional research delivers slow, discrete data points. On the right, social media provides a continuous, high-volume data stream. Capturing this flow at scale is social listening, the automated process of monitoring online conversations. To make sense of millions of text blocks, sentiment analysis classifies unstructured feedback into quantitative data, sorting text into positive and negative buckets. For example, a student post saying the UIEM system is user-friendly is flagged positive, while confusing and slow is categorized as negative. By transforming qualitative public opinions into quantifiable metrics, organizations instantly identify systemic weaknesses in their services. They can pivot their strategies and deploy fixes immediately, bypassing the wait for traditional market reports. Listening to stakeholders is only the first step. The next is co-construction. This is an active, collaborative process where stakeholders don't just provide feedback. They help organizations jointly create knowledge, solutions, and products. The computer science field actually pioneered this concept. Open-source software communities developing systems like Linux and Python are premier examples of co-construction, with developers worldwide collaborating to build and refine code together. But organizing this massive, constant influx of stakeholder contributions isn't simple. Basic keyword sorting isn't enough. Processing it requires advanced natural language processing and machine learning models to truly understand the context of what users are submitting. Let's test this. Look at the comment on screen. Oh, great, another UAM portal update right before exams. Exactly what I needed. Pause the video for a moment. How would a basic sentiment analysis algorithm classify this, and why would it be wrong? A basic system sees words like great and exactly what I needed, logging it as positive, but it completely misses the underlying sarcasm. To handle complex human nuances, effective crowdsourcing relies on adaptive NLP models, rather than relying on rigid keyword tracking. This dashboard shows where those NLP outputs end up. It maps the incoming data streams into 4 distinct quadrants: competitive intelligence, customer relationship management, innovation support, and crisis management. Global entities rely on these specific quadrants daily. Netflix analyzes audience conversations to predict content preferences and drive innovation, while Tesla uses the crisis management quadrant to monitor negative product experiences in real time. Right here at UUM, we utilize these same analytical principles. The university monitors its own social media channels to gather direct stakeholder feedback, manage its reputation, and continuously enhance student services. This brings us to the complete crowdsourcing pipeline, shown here in 3 stages. Stage 1 is the raw stakeholder input, generated constantly across various digital platforms. Stage 2 is the computational analysis, and Stage 3 represents the final strategic outcomes. Notice how Stage 2 holds the entire process together. Without the computational layer of natural language processing and machine learning, Stage 1 is just noise, and Stage 3 is impossible. Analytics form the indispensable bridge between raw data and usable insight. As you progress in the School of Computing, remember this pipeline. Mastering these computational tools elevates you from being mere software builders to becoming vital architects of an organization's long-term competitive strategy. Thank you for watching, and see you in the next chapter.